Good morning, Earth Science students. Friday, woo! 5/8/20. Okay. Wow, days are just flying by. Some of you might not be thinking that's the case. For me, they've been flying by. All right, learning targets today. We're going to be starting a new unit, and this unit's going to be on the rock cycle. So, 1, I can explain the difference between a rock and a mineral. 2, I can name 3 main types of rock and describe how they form. It's very possible that you guys already have today, or some of you already have today's down. You know, you can think back. You've had some earth science in middle school. Maybe you know 3 types of rocks. Maybe you know the difference between rock and mineral. If that's the case, it should be quick and easy for you. All right, so this is Unit 7, starting a new unit. We're expecting to still take some notes because notes help you remember things and retain things. And remember, that's really the goal, is to try to learn things. All right. Now, minerals are actually covered in a different chapter that I'm not covering in this class, but I'm going to give you this one-page little summary on minerals. Okay? A mineral is an inorganic, crystalline solid formed by natural processes that has a definite chemical composition. Boy, that sounds complicated. Here, I broke it down here into some bullets. Naturally occurring, okay? We're talking about natural substances out there in our world. Inorganic means it's not from living things, okay? Not from living things. It's a solid, so we're not talking about liquids or gases. Definite chemical composition. So if I have a mineral, it's made of a certain combination of elements combined in a certain way. And that mineral is the same wherever we find it on Earth. For example, if I'm looking at a piece of quartz, quartz is a mineral. It's made of silicon and oxygen, silicon dioxide. No matter where that quartz comes from, that's the composition of quartz. Okay? Ordered internal structure, crystalline. Okay, crystalline means the particles are lined up in a pattern. Imagine if you had a crate of oranges, and you're trying to fit the oranges into that crate as best you can. There's certain patterns to how you'd stack those oranges that fit better than if you just had them in a jumbled mess. Okay, natural substances. Many natural substances tend to have their particles fall into an orderly arrangement rather than just a jumbled mess. Now, there are some that are jumbled messes. They are non-crystalline. A stick of butter is not crystalline. Plastics are not crystalline. But minerals are crystalline. So what's a rock? A rock is a collection of mineral grains held together in a solid mass. Okay? Now, your rock could be all one type of mineral. So you could have a large rock that's all the same mineral held together, or there could be lots of different minerals stuck together in that rock. So there's a limited number of minerals out there. There's all sorts of rocks depending on how these things are put together. Our 3 basic types of rocks, again, I bet you recognize these names: igneous, sedimentary, and metamorphic. We're going to take a look at each of these in real basic terms today. Igneous rock is formed by the cooling and crystallization of magma or lava. So you remember, magma or lava is liquid rock. It's melted. So if you let it cool down, what happens is the particles start to line up with each other. That's called crystallization. The process where individual particles line up with each other and form a solid. Sedimentary rock. This is where pieces of pre-existing rock are compacted and cemented together. So we had some rock in the past, and that rock's gotten beat up, pulverized into little pieces: sand, pebbles, gravel, clay. And those little pieces now are getting squeezed together, compacted, squeezed, and something happens to cement them together. I just remembered something that I can use as a prop here. Give me about 5 seconds. All right, maybe that was 10 seconds. Effectively, I made a sedimentary rock here. What this is, I took some sand and I mixed in some iron filings and I mixed in some sugar, and then I got it wet and just packed it together. So what happened is the sugar would dissolve in that little bit of water. Sand and iron filings not so much. But then, as it just sat, the water evaporates and the sugar comes back out. And so the sugar kind of glues all the other particles together. And this is actually very, very solid. Maybe. It's a very solid piece. It feels like a rock. So effectively, I made a sedimentary rock because it's made of all sorts of little pieces. Now, when I rub on it, there's little bits of grit and stuff that come off. That's very common for sedimentary rock to do. Now, I got another one. It says, or minerals are precipitated from a solution as liquid evaporates. So let's try this one. If you went to an oceanside beach and you took some seawater, just take a big pitcher of that, pour that pitcher into a shallow tray and just let it sit and evaporate over a few days. You know that seawater is salt water. Well, what would happen is as the water evaporates, the salt that's in the water stays behind and starts to grow salt crystals. That would be an example of what's called a chemical precipitate. And sometimes when you have massive amounts of that, that is considered a sedimentary rock. We have other things. There's limestone deposits. If you've been in caves and you see the stalactites and the stalagmites, those are chemical precipitates, and they're made of rock. There's minerals that came out of solution. So to precipitate means to drop out or fall out of solution. We think of precipitation in our weather, where rain, snow, sleet, hail fall out of the sky. It was up there, held up in the air through the wind currents and stuff, and the particles got too big and they start to fall down. They fall out, precipitate out. Here we're talking about in a liquid solution. As the liquid is evaporating, the solid falls out. Evaporating means changing from liquid to gas. All right, metamorphic rock. So this is a case where you have extreme heat and pressure within the earth. So this typically happens down deep. It causes minerals in existing rocks to change in structure and or composition. So structure would be about how it's arranged. Maybe we just rearrange the particles a little bit. But composition is what it's made of. So if when you're rearranging these particles, you change the way they're bonded to each other, we might have new compounds made. Now, this is not melting. This is not igneous rock. We're saying we're going to change the structure of a rock. We're going to change the composition, but it never actually melts in between. We're just rearranging what's already there. Okay? If we melt it, and now that cools and crystallizes, that's just a new igneous rock. Now, all these things fit together. It's called the rock cycle. A cycle is this continuous process. One type of rock changes to another. So there is no beginning and there is no end. We could pick a point. If I had an igneous rock, what could happen? Well, that igneous rock could get broken down into bits. That's called weathering and erosion. And those bits are called sediments. And then those sediments could get compacted and cemented together, or we could have it dissolved in water and it precipitates out of solution. And now we have a sedimentary rock. What could happen next? Hey, that sedimentary rock could melt and form magma or lava. That magma or lava could cool and crystallize. We got a new igneous rock. So igneous rock could turn into sedimentary. Sedimentary could turn back into igneous. Maybe that igneous rock, instead of breaking down, it gets buried in the earth and it's subjected to heat and pressure, and earth, rearranges the particles into a new rock. That's a metamorphic rock. That metamorphic rock could be exposed at the surface now and wear away and weather and erode into sediments and then turn into sedimentary rock. The sedimentary rock could be subjected to heat and pressure and turn into metamorphic rock. Sedimentary rock could break back into new particles and become new sediments for new sedimentary rocks. Any type of rock can turn into any other type of rock. Okay? Now I listed 2 intermediate stages. Anytime we're going to igneous rock, we're going from magma or lava, so we got to form that first. And anytime we're forming sedimentary rock, we got to first form sediments, which are those little broken up particles. But then they can be compacted together into sedimentary rock. And this keeps going. All right, that's an introduction. You're going to have a section to read, maybe a couple questions to answer. Then enjoy your weekend. I don't think this was a terribly long assignment. Stay safe, have fun.